So welcome, everybody. My name is Jonathan. This is my colleague, Mark. We're both from Amazon Web Services. Our offices are actually not too far, like literally a few hundred meters. We're based in Berlin, actually. That's where the OpsWorks team is. So we both work on a lot of the Chef integration in AWS. And we're here to talk to you today about how you can run Chef at AWS, what kind of integrations we offer, and in particular, talk about compliance. We have some demos with InSpec and how you can run that with the various services that we offer at Amazon. So today, as I said, we want to focus on a little bit how can you run Chef on AWS. We want to talk about two of these integrations, one with OpsWorks, one with Systems Manager. And we have also a demo of how you do agentless and credentialless scans there. And then we want to talk about Config, which is Amazon's configuration compliance CMDB solution, and how that integrates with InSpec, how you can use for config rules, InSpec profiles as a way to ensure compliance. And then we will briefly talk about Security Hub, which is a new service that Amazon has, where you can kind of aggregate all reports from various tools into one dashboard. And we don't have a great story with Chef there yet, but I can kind of outline how this will hopefully look like very soon. We're very excited about partnering with Chef in these areas. So running Chef on AWS, right? So if you look at Chef, I think all of you are probably familiar with the various components that exist. And for all of these, there are kind of different ways to operate it, right? Like if you obviously want to have your own server, that's a different story from just executing the client, where you don't need a lot of help, most likely, right? In general, at a high level, you have two solutions or two ways to run the various tools that Chef offers on Amazon, right? Like you can do it yourself. You can just install the Chef server or install Chef Automate or like pre-package all the Chef client and InSpec on all your armies. You can use tools like Terraform. You can use tools like Packer to do it. Or you can use actually some of our integrations where you get more of a managed experience. So the one that I want to talk about a little bit and where Mark will give you a demo in a few minutes is AWS OpsWorks for Chef Automate. So that's an offering that we launched together with Chef actually now 3 years ago, where the idea is that together with Chef, we can offer you a managed version of Chef Automate and Chef Infra Server, where you don't have to worry about all the operational overhead of installation, of upgrading, of version management, of backup and restore, and so forth. Right? So how it works is you basically go to the Service Console or API or SDK. You say, I would like to have a Chef Automate and Chef Infra server in this region of that instance size. And then OpsWorks is taking care of launching it, installing all the necessary software dependencies, and then basically doing all the operational aspects of it, which we will talk in a second. But the whole idea is you now have a Chef Infra server and a Chef Automate installation in your own account. You have root access to this machine. You can customize it if necessary, but you don't have to operate it, right? You don't have to manage it yourself, and then you pay as you go per node. So we also integrate the billing for you and the support so that you pay as you go. You consume as much as you need in terms of payment for nodes, and you don't have to prepay for anything. And we also have a free tier of 10 nodes per month, roughly, right? Like we actually bill per node hour, so you can run more than 10 nodes if you don't run them for the whole month, but it roughly equivalents to 10 nodes running 24/7 for a month, or per month. Then some of the features that we offer you is we maintain and operate the server, as I mentioned, right? So that means operating system updates, that means any health checks, so the health of the server and replacing it. That means backup and restore. So you define a maintenance window where you can say every night I want to do a backup, or once a week I want to do a backup. You can restore machines, the same machine or other machines from this backup. We handle the operating system updates, also the Chef version updates. So like updates to major versions or minor versions is something that we do for you. Apart from this basic server management, we also integrate with a lot of the AWS ecosystem, right? And that's when we start to talk about some of the integrations with Amazon, right? So one feature that we do is obviously IAM integration, so identity and access management for AWS in terms of who can access the server on the API level itself. We have a starter kit that is easy to use. And then I think most importantly, the coolest feature that I find is the unattended node provisioning. So one problem that you have if you use Chef Server, Chef Automate is how do you actually authorize the various machines or the nodes to the server, right? Like you don't want to pass credentials per SSH, you don't want to hardcode them on AMIs. So what we did here is by integrating with the host credentials that you can have, right? Like if some of you are familiar with AWS or the EC2 metadata service where you get kind of ephemeral credentials per machine, Opsworks integrates with that capability so that nodes that run on EC2 can get credentials from the metadata service, can use these to request authorization to the Opsworks API and server, and that way we authorize the machine on the Chef server and Chef Automate level so that you don't have to manage credentials for that part at all. You can just have, let's say, an autoscaling group that launches and terminates machines on demand, and they get automatically registered and deregistered from the Chef server without any credentials being stored or hard-coded anywhere. And that's a very cool feature that lets you operate much more securely without any manual intervention there. And then obviously user data for like ASG integration, Terraform integration, CloudFormation, and so forth. So at a high level, that's kind of what Opsworks for Chef Automate gives you. And Mark is going to show you how once you have your server up and running, how do you now can use some of these capabilities to do agentless and credentialless scans, right? So once you have your own Automate server, how can you leverage the same metadata capability that I was just talking about to do scan operations, be it instance-based with run command or be it pure like API-based, so you can scan your resources. So, Mark?
Okay. So, let me switch over here. I was just disconnected from. So I have a server here. Basically, I have two servers here. I have Demo Boy and I have my ChefConf demo server, and I will use that one. So I go here. I've worked with that one. There's some scan jobs, some client runs, and everything. But the most interesting one for me is actually InSpec right now, and I want to focus on that. If you use an Automate server, you can go to Settings and click on Node Integrations. Let me delete that, and I can do that with you. So if you create a node integration, what you usually have is, you need a name, like EC2, and click on EC2. And now for node integrations, Automate asks you to either give access ID and secret access or read them from your environment. But who wants to bring credentials into a server? So no one that I know would do that, and we don't have to do that anymore. The cool thing is that we can leverage a couple of capabilities under the hood to run those scans without having credentials stored on your Automate server. I've seen that in a couple of demos that I did earlier, that people still use that. And how it actually works is we need to have an instance profile that gives capability to the instance itself that lets you do things like run command. And over run command, we can execute InSpec scans that report back to your Automate server. So you don't have to do SSH access to your instances. You don't have to bring credentials or anything like that. You just click on that. I haven't put anything else, save integration. And if everything is fine, it should tell me that it's reachable. It does, that's cool. And now let me do a scan. So most of you are very familiar with that. You create a scan job. And now I say EC2. And all of a sudden I see I have 11 nodes available without giving any credentials. And let me use US West 2. That's where we are, more or less.
So this is now the server itself scanning through this ephemeral credentials, scanning my AWS account, discovering that I have EC2 nodes in there, and then reporting them here, right? And through the run command integration that Mark was talking about, we can now actually run InSpec on these nodes.
What I also can do is I can have tags like name or something, and it's all pre-populated, and you can just click on which names or which servers you want to scan. I don't do that now. I'm fine with that. I click on next, and now I need to define a profile, and most of you have seen examples with SSH baseline profile. I will use that one. And I do a single scan. I don't do that multiple times. Scan EC2. Click on Save. So what now happens is that because my server has the ability to do run command scans, it is now triggering a run command on all of those machines. In that run command, it executes the InSpec scan, reports everything back to Automate, and then we can see the results. If I click here on results, I should see, oh yeah, I have 4 nodes, and not surprising to most of you, they're not compliant. That's not a big deal. We can use a hardening cookbook to apply that, and then they're all fine. But I'm not going into that. So you have seen multiple other workshops where that is done. So, but besides scanning EC2 instances, you can also scan the API of AWS. So there's a good integration that has multiple resources on AWS, like S3 buckets, EC2, IAM policies, and so on. And there are CIS benchmarks that let you run more securely, and I want to do that too. And the same I do here now is I need a name. That is the only boring part. And then I click on Save. Magically, everything is fine. And now I can scan those too. Just create a new scan job so that you see that I'm not faking it. I use the API scan. It shows me I have 17 regions here. I can use one. So, next. And now this here is AWS Foundations benchmark. That is actually scanning a lot of APIs. To make them all working for you, you need to have an instance profile on the server that lets you do those operations. There's API, so SDK calls coming, and you need to authorize those. I gave my server read-only access to basically everything in my account just to make it a bit easier for me, but that's not enough. So I have some of those scans will just not work. Not a big deal. I could actually dig a bit deeper into the CIS profile to see what permissions I need to give. So, yeah. So I see that my API scan is new. Now it's running. And in a couple of minutes, it should, or seconds hopefully, it should show me that it's done. Takes a bit. It's completed. So let me go over there and see, no surprise, I'm not compliant. And I see one node, and this node is not a node, but it is a region. And in that region, we scanned for all kinds of APIs. I have 27 major controls failing. Let me look into that one. Oh yeah, so I have an attach policy, and for those policies, there should be no username, but I have me, myself, and Simon. So I have to do something about it. But what I wanted to show you is that you don't need to bring credentials, you don't need to have SSH access, you don't need to have any kinds of credentials bringing to your server. If you just use the capabilities of IAM to say that my server has the ability to do all those operations for me, then you have a better control over it, and you don't need to rely on that everything is securely stored on your server. And if someone is hacking your server, they don't have any access to your AWS account. Okay.
Cool, thank you, Mark. Yeah, so this is one of the integrations that we wanted to talk about today, right? Like where the Chef Automate server integrates with the various AWS APIs. We saw EC2 run command to actually execute InSpec inside the machine. And then we saw also the scans of the resources themselves, like S3 buckets, or in this case, IAM users. Continuing to talk about InSpec, like how can you also run InSpec? Like maybe you're not using Chef Automate, the server piece of it, right? Like maybe you just want to do like ad hoc scans. So another way to run InSpec and also have these reports, by the way, feed into an Automate server if you have one, is using Systems Manager. Mark already was mentioning run command, and run command is a capability of Systems Manager. So what is Systems Manager? Systems Manager is the idea that how can we at AWS offer you like a management tool that helps you operate your resources. And in order to do that, we want to first help you group them using AWS resource groups. So the idea that you can create or model what applications you have or what projects you have into entities, and then address them later on using Systems Manager, using CloudWatch. We actually just recently launched an integration with a DynamoDB dashboard for this. You can then look at insights and operational dashboard with CloudWatch, and then most importantly to the piece that we will look at, you can then act, right? So you can do remediation with various tools. Systems Manager bundles a few of these capabilities in there. So we talked briefly about resource group. It can manage patches for you. It can execute commands. That's the one that we will look at in a second. But it also has various other capabilities, like running maintenance windows for you and executing certain of these actions on a certain time that you can do with State Manager. It can do what we call automation. That's you can think of this as kind of runbooks that you can execute, which can either be run command documents, or they can be CLI or SDK operations against your account. It can report it into an inventory. We will look at that in a second. And then parameter store is like a very simple key value store where you can define application level parameters that either feed into the services here, or you can actually use them in your application as a configuration. The important capability maybe to remember here is run commands. Run command is the ability to execute commands, as the name suggests, right, on your EC2 instances. We will leverage that to execute InSpec on the machines, right? So what we want to do is essentially either use run command on an ad hoc execution, right, or use State Manager, which you can think of as a scheduler for run command and similar actions, right? It does a little bit more than that, but for our purposes, that's probably a good enough understanding. Where you then target a document. So in Systems Manager, these executions are defined in a document. You can think of it as a little bit like your chef cookbook. It would be the equivalent, right? And then we can execute them on Windows and Linux servers, right? The run command document, and then the result gets reported into the compliance capability of Systems Manager inventory. So the idea here is, as an AWS customer, you can just execute a run command once, or you can use State Manager to have it run every hour or every day or whatever. You pick the built-in AWS run InSpec document. You run it on all the servers that have the Systems Manager agent installed, and then you get a report of which of these are actually compliant with the InSpec profiles that I picked. So if you use the Systems Manager console, you select this document. Then you can provide a source type for your profiles, right? So in this case, we have an integration with a Git repository, or GitHub in this case, where in this configuration down here, you define what is the branch, what is the repo name of the InSpec profiles that I want to execute. You can also define the GitHub token that should we use for that. You can see that information here, hopefully a little bit better. So that's the GitHub owner. That's the repository name. Then you can define the branch, and then you define the token that you can store in parameter store, how to actually connect to GitHub. That's the credential information. And then once you define that in a run command or State Manager execution, you can just execute it, right, ad hoc, or like I said, scheduled. What it will result in is that you can actually then see which of your managed instances with Systems Manager in this case are compliant or not compliant with the InSpec profiles. So in this case here, we have 2 managed instances, and both are not compliant and have some critical violations against these policies, right? So again, at the end of the day, this is just InSpec, but we're executing it through the integration with AWS. I don't need SSH. I don't need to open any ports. I don't need to add another functionality to my machine. If I use Systems Manager with run command to maybe leverage some of the other capabilities like patching or inventory reporting, I can just piggyback through that connection with InSpec and leverage the CIS profiles, for example, or my own policies that I've wrote, and use run command as the execution engine, right? Like that's actually what Mark was demoing earlier, what the server is already implicitly doing for you if you leverage the server piece. In this example, I don't need even to have a server. I just need my InSpec profiles, right? I don't need any other infrastructure. So that's the integration with Systems Manager, right? So we have now looked at 2 ways how we can actually execute and run the InSpec throughout AWS and what kind of integrations we have. Now I want to talk about config and highlight a little bit the other side of the reporting to a degree, right? Like how can we actually look at the reports and how can we consume them in a central place? Now, what is AWS Config? And the name, unfortunately, is not one that is telling a lot immediately. So Config is like our built-in solution that helps you to evaluate, on the one hand, policies against your resources, and on the other hand, track changes against your policies. So you can think of it a little bit like Amazon's built-in CMDB for all your resources on AWS, right? So the idea is that every time one of your resources changes, let's say somebody terminates an EC2 instance or like resizes an EBS volume, opens a port on a security group, like all of these kind of events, right? AWS Config is recording these changes. So every time a resource changes, Config reports it. Normally it stores this in a database, and it can also then evaluate some rules against them. We will look at them in a second. And then it can either notify you, it can automatically execute a Lambda, essentially, that does something to that. And it also stores them in history and gives you a nice report. At the end of the day, it serves kind of two purposes. One is as an audit functionality. What happened to my resources when and who did it, right? So imagine you have a bunch of EC2 instances, and you then discover that a certain group of them has port 80 open, but you don't want that port actually to be open. Using config, you can track like when was this port opened, through which API call that was triggered by which AWS identity. So you would be able to say, oh, like Mark actually opened that port yesterday, and you're able to kind of follow that through the lifecycle of the resource. And the other functionality is with config rules is you can then automatically respond to these state changes essentially, either by notification or by executing a certain Lambda actions, which essentially means everything you can do with Lambda against it. So one consequence that it could be like some of our customers, like they define, for example, in the production account, I never want to have port 80 open for particular groups of resources. And then they can define here with the API process, with the Lambda, that these EC2 instances will be automatically terminated. So that means if the same thing happens again, right, if I have this policy in place, somebody opens port 80 on a machine, config will automatically terminate it, for example, right? Like that's something you could implement as a config rule and as a execution result by that. So that's a pretty cool feature. Like I said, customers are using it to enforce these policies, to get notification of that, and we will see in a second again how can you plug InSpec and automate into these pieces. Today, config supports a bunch of services and resources. So like you can see here, over 24 services and over 60 resource types. Like obviously, over time, we want to support most, if not all, of our resources that we have at AWS. But pretty much the most important and critical ones are there, right? So you have EC2, you have S3, you have VPC and IAM, so kind of the typical have servers, they have certain configuration in terms of network configuration, in terms of hardware size, right? In terms of who has permission to what. Kind of those most important things are covered there. And like I said, we will then show you the history of these state changes. And then with config rules, as mentioned, you can then analyze these changes and automatically respond to that. We also have a large collection of pre-built rules. Like a good example is you most likely don't want to have an S3 bucket that is world writable, right? Or maybe even not even word readable, right? By default, like you want to say these buckets should not exist. I want to get a notification every time one of my employees creates an S3 bucket that is word writable. That should trigger an alarm somewhere, right? Like I want to look at it because probably it's wrong. And if it's right, then we need to code in an exception. So that's a perfect example of something you would be able to define in a config rule actually across several accounts and then enforce on your managed AWS accounts. You can also use community source rules. So we have a GitHub repo with a bunch of them. And as mentioned, a very interesting feature is that you can aggregate this into a central account, right? So usually most customers have many AWS accounts, and config can actually aggregate all of this compliance information into one. So what does it actually mean and how does it look like? So I have here an example of the state changes on a resource, right? So you can see here that the dates when this is when the resource was created, and here is when the resource changed, and you can see kind of the attributes that change as a JSON object. All of this information is also available on an API. so you can build your own tools on top. And this information is available in the Lambda call that gets triggered when these state changes happen, and they no longer adhere against the config rule. And with config rules, you can go even further and then say, when these changes happen, is my resource still compliant with the rules I defined, or is it no longer? So in this example here, we have an S3 bucket. And you can see here, right, like this, at that point in time, the bucket was still incompliant. And then something happened, right? Like 3 changes happened to this object, and it's no longer compliant. There were some additional changes, still not compliant, and so forth. And you can track these over time. You can click on each of these events, and then we'll see, okay, what happened, called by who, right? Who triggered it, and what are the rules that are no longer compliant. So in this example, it's now world readable, and that's why it's no longer compliant with this rule. And these rules, like I said, you can define your own. You can use some of the existing ones. You can use some from the community. And what Mark will show you actually how you can use InSpec as these rules, right, as the language to write these rules, so you can benefit from the big community of InSpec provided profiles.
Thank you, Jonathan. So let's go to my next demo. I need to get out of PowerPoint. So, yes. Okay, so Jonathan talked about config, and you as Chef users might ask yourself, why do we need that? We have InSpec, we have Automate, everything is fine. Actually, that's true, but most of the companies don't run everything with Chef. So most of you probably work in companies where some part is using Chef, some part is using some other configuration management, some part is using something completely different. So with if everything is on AWS, you have then at least one tool where you can just say, okay, I know how I would evaluate that things are compliant with InSpec, and I can aggregate that together with other compliance regulations that I have for my AWS account into one tool, which would be then config rules. So I set up a basic InSpec rule, and that is not doing too much. It's just getting an InSpec profile from S3 in that case, and there's only one thing in there that is asking if NTP is installed. So a server without NTP is not something I would like to run. And I can see I have a non-compliant and I have 3 compliant servers in my account. So now the question is, how can I make that more compliant, right? So let me first tell you a little bit how that is how it's running. So Jonathan already said that if you have a custom config rule, it is triggering a Lambda. In my Lambda, I'm now just using, again, systems manager run command to pull down my InSpec profile, execute it on all instances that are accessible to my rule, and then report back here. And now I see I have a non-compliant instance. And because that instance is not under Chef management, I still need to fix it somehow. Now I can SSH to that instance, doing bash or whatever. Or I use the Chef workstation. So that's hopefully, I'm not 100% sure, but I think that should be the instance that doesn't have my NTP package. And with workstation, I can just execute a very simple snippet of Chef code or even a complete cookbook, for example, the hardening cookbooks, and install something. So in my case, it is using SSH access, running then Chef on that instance, and it should install NTP. And if I didn't pick the wrong instance, that should actually make it compliant again. So as you can see, it generates a policy file. Everyone who is still using roles, look into policy files. It's much cooler. And it's applying that package. That's about it. So let me see if I reevaluate my config rule. It takes about a minute or so. Because it's triggering a Lambda that triggers run command. It needs to get back to us. So maybe 2 or 3 minutes it might take. And then at some point when it's done, I should have only compliant instances.
Yeah, and usually you wouldn't manually execute this, right? Like you would look at your daily, weekly, monthly compliance report, right? Where this information will be aggregated, and then you can delegate it to the various teams. The cool thing about this integration is you can use the InSpec profiles, right, like the public ones, your own ones, you can use kind of one DSL and language to write them, but then you're leveraging the built-in integration and compliance database with Amazon, right? So, and like Mark mentioned, this also helps you to execute against machines or nodes that are not managed by Chef necessarily, right? So in this case, these instances don't have a Chef client installed, and we're still able to get them compliant. In this case, we use kind of a hacky Chef workstation, right? But whatever kind of the ways that you usually enforce that on your machines, be it in Chef, be it by baking new Army, whatever it is, you can leverage InSpec to have all of this reporting be in config together with all the other reports and compliance scans that you have.
So it looks like I sacrificed enough to the demo gods. So it worked. I'm happy. I have nothing non-compliant. So everything has NTP installed. Everything is cool for me. So it comes back. Why I want to show you that is you can help with InSpec and with Chef people in other parts of your organization that are not using Chef to actually make things more compliant. So you can help them with InSpec profiles to make things done right, and you can help them to actually harden their servers, even if they are not willing to use Chef or if they are not able to use Chef for whatever reasons. So you can actually help them even if they are not yet fully on board with Chef, and then maybe they will see the magic and might come along. So
yeah, maybe we can show briefly the config rule, kind of just at a high level, how it looks like, how you would create your custom rule, essentially.
So yeah, that's really basic. So I just have a name and a description, and then this is the Lambda that I'm running, and I think I can link over to that one here. So here's my Lambda. Need to scroll a bit. And that's the code. We used a basic Lambda example, and that's the whole code we do. So it is just using a get command invocation, which is systems manager run command. And it's executing that here. And then depends on the response code of run command. We either say it's compliant or non-compliant and get that back to our config rule.
Yeah, but essentially, right, like with the config rule, we're saying what are the resource types we want to subscribe to, any state changes. So in this case, we said EC2 instance is what we want to subscribe to. We trigger a custom Lambda. So this Lambda function gets past all the context of this state change, right? Like in the slide earlier, I showed like a JSON side that had this is the attributes before the change, this is the attributes after, and then you can in your Lambda evaluate if they're still compliant or not, right? Like in this case, we will actually not do it inside the Lambda. We will execute a run command to run InSpec, but for the example that we had with the S3 bucket, you would inside your Lambda function, you could have the code and the logic that says, what are the attributes of this bucket? Does this bucket have the flag public to readable set? And if yes, we report is not compliant, and if no, everything is fine, right? So you can have any custom logic in there, any Lambda execution engine, right? Java, Ruby, Python, and so forth. You can run with that. So it's very flexible. That means how you write your compliance enforcement or your policies is very dependent on what you prefer, right? Like you can write them in Lambdas, you can write them in InSpec, and so forth. Cool. So the last thing I want to talk about is how we envision long-term all of these integrations to come together. This is maybe a little bit forward-looking and take it with a grain of salt because these integrations are not completed, but just to give you an idea of how we think about this and what we're excited about to be able to work, hopefully in the future, closer with Chef about how can this be integrated, right? So, some of you might be aware that we launched actually at last reInvent a product called Security Hub at Amazon. So the idea of Security Hub is how can we bring together all of these reports, all of these compliance and security-related issues that are reported either by Amazon-provided tools like Inspector, by external partner tools like Chef, and have them report into one place. So this is essentially what Security Hub does, right? So you have this dashboard where you can surface some of these high priority reports, and then today it integrates with GuardDuty, with Inspector, and with Macy, and then most importantly, it also has a way to integrate with partners. right? Today, we have, I think, a handful of here, and we're working with more partners to give you additional integration and surface that in the dashboard. But the idea is pretty much the same, which is each of these various either built-in or partner-related software and does the various scans, security-related, CIS, compliance, right? Like governmental regulations, whatever you say, okay, here's a regular scan that I need to do, antivirus, compliance with InSpec, right? Like you can then have this report into the central place where then maybe your central security team, maybe your audit team, right? Maybe the individual teams in your organization, depends on how you set it up, have like this high-level dashboard. So here's an example of how it would look like today. Like this is in my account if I just logged in. So it's a little bit boring because I have no findings with these tools. But you can see here, right, like there are some top insights, and then there you can scroll down, and it will show a lot more things about here's some issues in this account. It can also do the aggregation. And then, like I said, if I would have additional partner software enabled, it will show up here. So that's how we imagine long-term this to look like with all of these different ISVs kind of feeding into this central console so that no matter what integration you use, right? Like no matter what of these pieces you run on AWS, you have one place to look at it. And then you can run InSpec, you can run Chef Automate and have all of this feed into this. So this is basically at a high level how you can integrate Chef today in AWS, how you can run it. Like I said, we focus on the compliance piece. Obviously, we could have talked for hours how you can use Chef itself, kind of the DSL to provision AWS resources, to manipulate them and so forth, and to configure applications. So that's everything we had, and now we have a few minutes to go over any questions you might have. We also have a booth here, so if you have more questions or if you want to see a demo of all of these things, and want to walk through us step by step, our several engineers from the OpsWorks team are here. We have some of our solution architects are here, so feel free to approach us afterwards. We're here all day. So thank you very much. And are there any questions? Yes, please. So yeah, the question is, how do we calculate the cost for Chef Automate on AWS? So we charge you per hour, right? So per managed node. So if you have one instance that does like a Chef run or an InSpec run on it in a certain hour, then you get billed for 1 hour. That means that if you have many instances that only run for a short duration of time, right? Like you do a burst with auto-scaling, then you get charged for that. And if you shut them all down, like you don't get charged anymore. So it's consumption-based pricing, very similar to like how you would get charged on EC2 or any of the other services. The granularity is an hour, right? Where as long as you execute something Chef-related, if you like, either a Chef run or like with a Chef client, right? Or you report compliance status into Chef Automate, or you do like an InSpec run, then you get charged. If you use this server-based feature that Mark was demoing, where you do agentless scan, then we use the same kind of pricing logic per resource. So in that sense, it's always dynamic on what you consume. And as I was mentioning at the beginning, there is also a free tier that lets you roughly run 10 nodes per month without any charge, right? But that, strictly speaking, is not limited to the number of nodes. It's, again, on the hour based. So that's just roughly what it equivalents to. But you could run, for example, 20 nodes if you only run them for half of the months, for example, right? Any other questions? Yes, please.
The integration where you're actually scanning the AWS account itself.
Yes.
For handling multiple accounts, would you just configure that same integration for each of those accounts?
So the question is around the agentless scan integration that we demoed with the Automate server and how it would work if you have multiple accounts. And Mark, feel free to jump in if I'm saying something wrong. The answer, unfortunately, is not as easy there because the credential that is used to do the scan is the one that is provided to the machine with the metadata service, right? And that is bound to the account where the machine is in and originating. I'm actually not sure if the integration today supports impersonating multiple accounts. That's something I need to get back to you too, because you can bind a role to the server, an instance profile to the server that has permissions to access other accounts, but then the server piece has to do the assume role piece, and I'm not sure if
I think it does.
It does it? Okay. If it does it automatically, then it should work. Then you should be able to grant it a role that has access to multiple accounts.
It's a bit tricky to set up, I must admit, but I've seen that it works from one of my SAs that was a bit more familiar with IAM. I'm not doing too much cross-account, but the assume role works, and then you should be able to scan across multiple accounts.
Yeah.
If there's any issue, I think it's better to reach out to us, and we can connect you to the SA that set it up, because I'm not able to do that right now.
I think that's in general like a pain point that we're working on to improve. Like how can we, not only in OpsWorks, but also I think in AWS as a whole, you will see us doing more and more about making it easier to manage multiple accounts, right? Like reporting into a single account, executions across account boundaries. I think that's a common problem where we need to give you a better experience. Cool. Yeah, any other question? If there are no, oh, yes, please.
Are those features for integration, are those available if I just spin up Chef Automate,
Yes.
like outside of OpsWorks?
So the
Specific to OpsWorks.
So the question was which of these features are specific to OpsWorks and which of these features are available if you just run Chef Automate server yourself. So everything that we demoed is available independently of OpsWorks, right? The OpsWorks piece has kind of the node registration and authentication piece that I was talking about in the beginning. That is OpsWorks specific, where you don't no longer have to handle authorization yourself between the nodes and the server. And then OpsWorks does more the operational aspect of actually the burden of operating a server, right? Like that I was speaking in the beginning. But once you have it up and running, the agentless and credentialless scanning is available the same way if you run it yourself or if you run it with OpsWorks. And then the pieces that we showed with config and InSpec running through a run command, that actually has no server component in there at all, right? Like that's literally, you need to have the systems manager agent installed in your machines, but then you can just leverage InSpec integration through the built-in document. Cool. And then another question over there.
With Automate becoming more open source now,
Yes.
is there a licensing model that will change with OpsWorks?
So the question is around the license change that happened with Automate and InSpec server, like how does it impact OpsWorks? So we work very closely with Chef and partner there, right? This is kind of a joint offering essentially. So today, if you're an Automate customer, you already have licenses for Chef Infra and for Chef Automate through this. So that the license change actually doesn't impact you too much. Apart from now, you actually also get access to the source code. We're partnering with Chef to figure out like what can we now offer in addition. Like given this change, what does it mean for our customers? Like should we offer like certain components of that package differently? That's something that we're currently trying to figure out, and we're actually very interested to hear your feedback, what you, our customers, and Chef's customers think. But today, if you launch a Chef Automate or OpsWorks for Chef Automate server, you get on this machine, you get Chef Infra server and Chef Automate, and we handle all the license implications with Chef through that hourly pay that we were mentioning earlier. And then in the very back, please. Yes, we do support bring your own license. So if you have your own existing license with Chef, then please approach us on the website. If you go to the product page of OpsWorks for Chef Automate, there is basically a link of how you can contact us. Okay. Cool. So yeah, thank you very much, everybody. Like I said, we have a booth. We're there if you have any more questions, anything to follow up on. And then, yeah, enjoy the rest of the day here at the conference. Thank you.